Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 3 from summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 7 to 12, which account for 19 of these marks. AQA Paper 3s are calculator papers, so a calculator should be used. A little disclaimer: there's more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 7. This week, Liam works 25 hours at £10.20 per hour and extra hours at the weekend at £11.80 per hour. Here are the extra hours he worked at the weekend. So he worked Saturday from 7 AM to 10 AM. So that's 3 hours. And then Sunday 1 PM to 3 PM. So that's 2 hours. In total, how much has he paid this week? So first of all, he's worked 25 hours at £10.20. So let's work out what that is. So 25 times £10.20 is £255. Now we need to work out how much he's paid for these extra hours. Well, there was 3 hours on Saturday, 2 hours on Sunday, so that's 5 hours in total. So we're going to do 5 times the extra hour hourly rate. So 5 times £11.80, which is £59. And then we're going to add those two together. So 59 is already on my calculator, plus the 255 is a total of £314. So pop that on our answer line. Question 8. 3 oranges have masses of 60 grams, 70 grams and 85 grams. Show that their total mass is between 1/5 and 1/4 of a kilogram. Okay, so if we're looking at comparing their total mass, let's find out what their total mass is. So 60 plus 70 plus 85. 60 plus 70 plus 85 is a total mass of 215 grams. So we want to show that it's between 1/5 and 1/4 of a kilogram. So 1 kilogram is equivalent to 1,000 grams. So if we find a fifth, so 1/5 of 1,000, so 1,000 divided by 5 is 200 grams. And then 1/4 of 1,000, so 1,000 divided by 4 is 250 grams. So we can say that 1/5 is 200 grams, which is less than the 215, but 215 grams is less than the 250. So we've shown that that value is somewhere between 1/5 and 1/4. Question 9. For each statement, tick the correct box. So we've got boxes for always true, sometimes true, and never true. So first statement, one of the 3 angles of a triangle is 90 degrees. Now we can have a triangle that has a 90-degree angle, and it's a right angle triangle. But there are more triangle types than right angle triangles. We can have scalene triangles where none of the angles are the same. We can have isosceles triangles, equilateral, etc. But there's only one option for a triangle that we can have a 90-degree angle in. So it's not always true because we've got those different types of triangles. It's not never true, so this one's sometimes true. So sometimes one of the 3 angles of a triangle is 90 degrees. Next statement, one of the 3 angles of a triangle is obtuse. Now the definition of an obtuse angle is greater than 90 degrees, but less than 180 degrees. If we have an angle greater than 90 degrees, we could potentially have extremely small acute angles, but we couldn't have more than one obtuse angle in a triangle. and there'd be very few cases where that occurs. So it can't always be true, but it could sometimes be true. And the final statement, one of the three angles of a triangle is a reflex angle. Now the definition of a reflex angle is that it's greater than 180 degrees. Angles in a triangle add to 180 degrees, so it is not possible that one of the three angles of a triangle could be reflex. So that's never true. Question 10a. Simplify fully p squared times by p. So what we need to remember is that this p has that invisible power of a 1, and the laws of indices for multiplication say that if they have the same base, which they do, p is the base, then we can simply add the powers to simplify. So we're going to have p to the power of 2 add 1, which is p to the power of 3, or p cubed. 10b. Simplify fully. 3a plus 5c subtract a plus 6c. So we're going to collect like terms. So first of all, I'm going to deal with the terms that have an a in them. So 3a subtract a. It's important that we use the sign in front. So 3a subtract a is 2a, and then positive 5c plus 6c is 11c. So 2a plus 11c, because that 11c was a positive answer. Question 11. Two angles around a point are shown. So we've got these two angles here, this angle and this angle, both around that point. The angles are in the ratio 2 to 7. Show that the larger angle is 280 degrees. Now, angles around a point sum to 360 degrees because it's a full circle. So that 360 degrees, we're going to share it into this ratio 2 to 7. So 2 plus 7 means we have 9 parts of the ratio in total. So we're going to divide the sum of the angles, 360, by 9. Remember, it's a calculator paper. 360 divided by 9 is 40. So each part of the ratio is worth 40. The smaller angle and the larger angle. So the smaller angle is 2 times 40, which is 80. And the larger angle is 7 times 40, which is 280. It wants us to show that the larger angle is 280. Just label it in some way to identify which one you believe is the larger angle, and then we're done. 12a. We have c is greater than 4, d is less than 4, and c subtract d is equal to 6. Work out a possible pair of values for c and d. So we want a value for c that's greater than 4 and a value for d that's less than 4, that when we subtract the value of d from the value of c, we get an answer of 6. So possible options for c then could be, it's got to be greater than 4, so we could have 5, 6, 7, 8, 9, etc. For d, less than 4, so we could have 3, 2, 1, 0, minus 1, etc. So we want to take a value of c that when we subtract the value of d, we get a difference of 6. So here we could go 7, subtract 1. If c equals 7 and d equals 1, c subtract d becomes 7 subtract 1, which is 6. So let's go with those. You could also have had 8 and 2 because they've got a difference of 6, 9 and 3, but that was the first one that I spotted. 12b. W is greater than 1 and less than 2. X is greater than 0 and less than 1. W plus X is equal to 2.6. Work out a possible pair of values for W and X. Okay, so what I'm going to do is I'm going to start with a value of W that is greater than 1 and less than 2. So let's go with W equals 1.9. So if W equals 1.9, which is greater than 1 and less than 2, then I'm going to pop that value in there. So 1.9, substitute for W, plus X equals 2.6. So x is equal to 2.6 subtract 1.9. Now what I want is this answer to be less than 1 but greater than 0. Okay, so the answer is 0.7, which is greater than 0 and less than 1. If it wasn't, then I would go back and try another value of w between 1 and 2 until I found a value that fell between 0 and 1 for x. So we're going to say that w can be 1.9 and x can be 0.7.